Imagine walking into your kitchen. You open the fridge, you grab that carton of milk, and you instinctively check the date on the side.
Right. You know it has a clock ticking on it.
Exactly. It's
Yeah.
perishable, it's going to spoil, you expect it. But now I want you to mentally walk outside and look at that, that massive metal box sitting on a concrete pad, your HVAC unit.
Most people, when they look at that box, they see a permanent part of the house,
Yeah.
like the foundation.
Right. You think, I bought this, it's just there. But we have a source today that suggests that big metal box is a lot closer to that carton of milk than any of us want to admit. We're looking at a really jarring advisory from Derek Cole. He's the general manager of Simmons 1 Hour Heating and Air. And this isn't some generic advice. It's dated February 17th, 2026.
And it's specific, very specific.
It's specific to North Carolina. And honestly, the numbers he's throwing out they're uncomfortable.
They are uncomfortable, but they're necessary. Cole has been in this industry for over 2 decades. You've seen him on places like NBC, CBS, so he's not just guessing here. No. He's looking at field data from the Sandhills, from the I-95 corridor. And the picture he paints is that our heating and cooling systems are living on what he calls borrowed time.
That phrase really stuck with me, borrowed time. It implies that, we think we own something, but really the clock's already run out on it. So if you own a home, specifically in this humid, hot slice of the country, we really need to talk about why your system might be dying years before you think it should.
And we need to be clear, this isn't just about things breaking. It's about the whole life cycle of modern machinery in a pretty hostile environment.
Okay, let's get straight to the hard number, because I think if you polled 10 people and asked how long should an AC unit last, you'd get answers like 20 years, maybe 25.
Oh, at least.
I remember my grandfather's unit sounded like a jet engine, but it ran for 30 years.
That is the nostalgia talking, and it's a dangerous metric to use today.
Oh.
According to the data Cole is sharing, for that Sandhills and I-95 region, the average lifespan is now 12 to 15 years.
12 to 15, that's surprisingly short. I mean, if I bought a car and it was basically scrap metal in 12 years, I'd be pretty upset.
Well, let's look at that car comparison for a second, because it actually proves the point. How many hours a day do you drive your car?
Maybe 1, 2 on a busy day.
Your HVAC system in a North Carolina July is running 8, 10, maybe 12 hours a day. In terms of run hours, a 10-year-old air conditioner has way more mileage on it than a car with 200,000 miles.
Wow. I never thought of it like that.
And Cole points out that the heart of the system, the compressor, is engineered with a very specific design parameter.
Which is?
It's built for a 10-year life cycle.
Wait. Engineered for 10 years. Are you saying they designed it to fail?
Not to fail, no, but to endure a certain amount of mechanical fatigue. Think of the compressor like the human heart. It has a finite number of beats. It's a mechanical pump under immense pressure. After 10 years of compressing that refrigerant gas, the valves wear out, the bearings get loose, the electrical windings degrade. It's not a conspiracy, it's just material science.
So when we get to year 12, we aren't just talking about a breakdown out of bad luck. We're talking about a machine that has mechanically reached the end of its natural life.
That's the reality. And this is where the domino effect really comes in.
Yeah.
Let's say you have a compressor failure at year 13.
Right.
You can replace that compressor. But think about what you're doing. You are putting a brand new heart into a 13-year-old body.
The rest of the system, the coils, the fans, the wiring, it's all still old.
It's all been vibrating and heating up and cooling down for that same decade. Cole emphasizes this. A repair doesn't rewind the clock.
So you fix the compressor.
And the evaporator coil is still thinning out. The capacitor is still weak. Reliability just drops off a cliff after that 10 to 12-year mark because you're just chasing the next weakest link in the chain.
Okay, so the equipment itself has a limit. But why is this specific region, the Sandhills, the I-95 corridor, so tough on them? Is it just the heat?
It's not just the heat. I mean, Arizona is hot, right?
Right, and units seem to last there?
Arizona is a dry heat. North Carolina is a wet heat. And that moisture, that humidity, is a silent killer for machinery. Cole identifies the North Carolina environment as a specific aggressive villain in this story.
He uses the word relentless, which, if you've ever been here in August, you get it.
It's not just uncomfortable for us, it's a chemical attack on the metal. Humidity is water vapor, and when that water vapor sits on metal components, the aluminum fins, copper tubing, it triggers galvanic corrosion.
So the air itself is literally eating the machine.
Slowly, yes.
Yeah.
from the inside out. And it's not just the metal. Moisture is terrible for electrical components. It corrodes the contacts, the switches.
And what does that do?
When a contact gets corroded, it creates electrical resistance. Resistance creates heat, and excess heat just destroys motors and capacitors. So the humidity is attacking the structure and the nervous system of the unit at the same time.
And we haven't even touched on the stuff that, grows in that moisture. The source mentions biology.
Right. Mold, algae, bacterial growth, especially in a crawl space or the indoor air handler. If you have a damp crawl space, your unit is basically breathing in swamp air 247. That biological growth coats the indoor coils.
Which acts like an insulator, right?
It acts like a winter coat.
Yeah.
You want the coil to be cold so heat can transfer from the air to it. If that coil is covered in a layer of, biological slime or dust, the heat can't transfer.
So this system has to run twice as long to do the same amount of cooling.
It's working harder to produce less comfort.
And working harder means dying sooner.
Exactly. And that's before you even get to the outdoor pollution. The pollen, the dust. That outdoor unit is basically a giant vacuum cleaner sucking in every particle in your neighborhood, clogging its own ability to breathe.
Okay, I get the environment part. It's hostile. But I want to go back to my grandfather's unit, the one that ran forever. You called it nostalgia. But the fact is, those old units did last longer. Did we just forget how to build things?
We didn't forget. We just changed the goal.
Yeah.
This brings up the beer can analogy that Cole talks about, and it's really crucial for understanding the modern market.
The beer can. Okay, explain that.
So picture a beer can from the 1970s. You could stand on those things. The steel was thick, heavy. Now picture a soda can today.
You can crush it with 2 fingers. Flimsy.
Old HVAC units were the 1970s beer can. Thick copper coils, heavy steel cabinets. They were tanks. They took a beating and just kept on running. But, and this is the big but, they were incredibly inefficient.
They used a ton of electricity.
A massive amount. So over the last few decades, the Department of Energy and all of us as consumers, we've demanded higher efficiency. We want lower power bills, high SEER ratings.
SEER is just the efficiency score, basically.
And to get a high SEER rating, you have to transfer heat very, very quickly.
And how do you do that?
You increase the surface area of the coils, and you make the walls of the tubing thinner.
Thinner.
Thinner metal allows heat to pass through it faster. Just basic thermodynamics. So manufacturers moved to these high-efficiency designs with very thin aluminum or copper tubing.
Ah, I see where this is going. We made the walls thinner to save money on our electric bill, but thin walls are just weaker.
That's the trade-off.
Yeah.
We traded a 25-year lifespan for, say, a 40% reduction in our monthly utility bill. Those thin coils are efficient, but they're fragile. They corrode faster in the humidity. They develop leaks much easier. They just can't take the abuse the old tanks could.
That makes so much sense. It's not that they're cheap junk.
No.
It's that they are high-performance instruments, like a race car versus a dump truck.
That's a perfect analogy. And because they're high-performance instruments, they are much more sensitive to how they are treated. Yeah. You could neglect an old unit and it would just chug along. If you neglect a modern high-efficiency unit, you kill it.
Which brings us to the part where we, try to solve the problem. If I have one of these fragile, high-efficiency units, how do I get it to year 15? How do I stop it from dying at year 8?
The first line of defense is, it's shockingly simple, but most people fail at it.
The filter.
The filter.
The 30-day rule.
Every 30 days. No exceptions.
Okay, play devil's advocate for me here. I'm busy. I forget. I leave the filter in for 3 months. The system is still blowing cold air. What's the actual physical damage? Why is that such a critical mistake?
It's all about static pressure. Imagine trying to run a marathon while breathing through a coffee straw.
I'd pass out.
Your heart would explode. That is what you are doing to your system's blower motor. When that filter gets clogged, the resistance to airflow, the static pressure, it skyrockets. The motor has to spin harder and run hotter just to pull air through that wall of dirt. You are literally overheating the internal components every single time the unit kicks on.
So I'm shaving time off its life just by being lazy with a $10 part.
You are. You are artificially aging the entire system. Cole mentions they even offer services to deliver filters to your door because it is that critical. It is the single highest return on investment task a homeowner can possibly do.
Okay, filters change. What about the stuff I can't do? The seasonal maintenance, is that really necessary or just an upsell?
It's not an upsell. Think about that outdoor unit we talked about, the one sucking in all the pollen.
The giant vacuum cleaner.
Exactly. If those tiny metal fins get clogged with dirt and pollen, the unit can't get rid of heat. They can't get rid of heat, the compressor overheats, Cleaning those coils is like taking a winter coat off the unit in the middle of summer. It lets the system breathe.
Okay, so maintenance is key. But there is another factor in the notes here that really surprised me. Cole says this is actually more important than the brand name on the unit.
Installation.
Yeah, this feels like the part everyone just glosses over. We shop for the box. I want a train or I want a carrier. We don't shop for the install.
And that is the fatal flaw. In the HVAC world, the equipment is just a component. The system is what gets built in your house. And the most critical parts of that system are the ductwork and the sizing.
Explain sizing, because my first instinct is bigger is better.
Right.
Why not put a massive unit in so it cools the house in 5 minutes?
That is the absolute worst thing you could possibly do. It leads to something called short cycling.
Short cycling?
Think about driving your car. What causes more wear and tear? Cruising on the highway for an hour? Or stop-and-go city driving where you're turning the engine off and on every block?
Stop and go, obviously.
An oversized AC unit cools the house too fast. It turns on, blasts cold air for 5 minutes, satisfies the thermostat, and shuts off. 10 minutes later, it turns back on, off, all day.
And every time it turns on, that's a major stress event.
The startup is the most violent moment for a motor. It takes a massive surge of electricity to get that compressor spinning. If you do that 50 times a day because your unit is too big, you are hammering that compressor to death. You want long, steady run cycles. That's where efficiency lives.
And the ductwork. You mentioned the straw analogy.
If the ducts are too small, which is incredibly common, you have that high static pressure built in permanently. It doesn't matter how clean the filter is. The ducts themselves are choking the unit. Cole points out that a bad install, bad sizing, bad ducts can cut the life of a brand new system in half before you even turn it on for the first time.
So you could kill a 15-year system in 7 or 8 years just by hiring a company that doesn't do the math right.
Easily. It happens every single day. That's why Cole says the install is more important than the sticker on the side of the box.
This is a lot to take in. We have a hostile environment, we have fragile but efficient equipment, and this critical need for perfect installation and maintenance. But let's fast forward. I'm a listener. My house is 13 years old. The system's making a weird noise.
The turning point.
Exactly. I call a tech, and he says, it's the compressor. It's going to do $2,000 to fix. My gut reaction is, well, a new system is $10,000, so I'll save money and just fix it.
And that is the financial trap. This is where we have to go back to that concept of borrowed time.
Okay, walk me through the math. Why shouldn't I spend the $2,000?
Because you aren't buying reliability. You are buying time. And usually, not much of it. If you spend $2,000 to replace a compressor in a 13-year-old unit,
I still have a 13-year-old everything else.
You still have a 13-year-old evaporator coil that's probably about to leak. You still have a 13-year-old fan motor. You're just waiting for the next thing to go.
So I spend the $2,000 today, and 6 months from now the coil blows, and that's another $1,500.
Correct. And all the while, you're still paying higher electric bills because that old unit is just not efficient compared to a new one. Cole's philosophy is that once you pass that 12-year window, the system owes you nothing. It has done its job.
Any money you pour into it is just rent.
You're renting your own air conditioner. It's a painful way to look at it, but it's accurate. You're renting a few more months of operation from a dying machine. And at some point, the system collects, as he puts it.
The physics catch up.
They always do.
Yeah.
It makes more financial sense to take that $2,000 repair money and use it as a down payment on a system that have a full 10-year warranty and will lower your bills immediately.
It's taking the emotion out of it. Stop hoping it'll last forever and just look at the ledger.
Precisely. It's asset management. A 14-year-old AC in North Carolina is a liability, not an asset.
So as we wrap this up, let's recap because we've covered some really dense territory here.
Sure. I think there are 3 main pillars to take away from Derek Cole's advisory.
Hit me with them.
First, reset your clock. If you live in this part of the country, 12 to 15 years is the target. Stop expecting 25. The engineering and the environment just don't support it anymore. Respect the trade-off. We chose efficiency. We chose lower bills. And the price for that choice is equipment that's physically more delicate. It needs protection, clean filters, clean coils to survive.
And the third?
Installation is everything. Don't just buy a box. Buy a system that is sized and designed correctly for your home. Or you're just paying for a slow-motion breakdown from day one.
It really reframes homeownership. You know, we tend to look at our homes as these static castles, but really they're systems, they're machines. and they wear out.
That leads to a provocative thought I've been mulling over while looking at all this.
What's that?
If we're moving into an era where appliances are designed with these sort of strict expiration dates, where efficiency mandates fragility, are we really owners of these systems anymore?
What do you mean by that?
Well, think about the software model. You don't buy software anymore, right? You subscribe to it.
Right.
If you have to replace your HVAC every 12 to 14 years, and you're constantly paying to maintain it, you aren't really buying a permanent fixture. You're essentially paying a long-term subscription fee for comfort.
That is kind of terrifying, but I guess it helps with the budgeting, if you think of it that way.
It does. If you view it as a subscription cost, I pay this much per year for climate control, then the big replacement isn't a shock. It's just the renewal of the subscription. It shifts the mindset from repairing a broken thing to renewing a service.
I think I'm going to need a minute to process the idea that my house is just a series of subscriptions wearing a trench coat.
It's the modern world.
Well, while you ponder that existential crisis, do yourself a favor. Go check your filter right now. If it's gray, throw it away. Don't let your system breathe through a straw.
Your wallet will thank you.
Thanks for listening to this deep dive. We'll see you next time.